What we're looking at today is a continuation of what we did yesterday, talking about logarithms. By definition, a logarithm, by the definition of logarithm, it follows that a logarithmic function, g of x equals log base b of x, is the inverse of the exponential function. Is by definition the inverse of the exponential function f of x is equal to b to the x. This means g of f of x, log base b of b to the x is equal to x. When what's inside the logarithm is the same as the base, they simplify out. Also, if we put b to the log base b of x, they simplify out as well. So they're going to simplify out in either way. They undo each other. So if we look at this first one here, 10 to the log of 4, well, since there's not a base written for the logarithm, it is understood to be 10.
John, if you can hear my voice, please come to the office.
So since we have log 10 to the log base 10 of 4, the log in the 10 would simplify out, leaving us with 4. Because 10 to the log base 10 of 4 would simplify out to be just 4. Log is just logarithm. It is the inverse of an exponential function. So any questions on this here so far? Now the other one that we have is that we have log base 5 of 25 to the x. Log base 5 of 25 to the x. Now, if we have log base 5 of 5, the base and the logarithm with base 5 and 5 would simplify out. This would simplify out completely, except for whatever the exponent is. Now, luckily, we can rewrite 25 as what? How can we rewrite 25 as a 5 to a power? It'd be 5 squared, because luckily 25 is 5 squared, which means you really have log base 5 of 5 to the 2x, because our powers of powers multiply. So since the base and the number inside of the logarithm match up, it means that these will simplify out, leaving us with just 2x. So log base 25 to the x is 2x. Any questions on any of these here so far? So let's look at these next two. So we have 10 to the log of 18. So we have 10 to the log of 18. And what would this be? It would be 18. Because 10 in the log base 10 would simplify out, leaving us with just 18. And that would be our answer. So we can look and see, because we would have to change 16, and 16 would be 4 squared. So yes, it is most likely going to work out to be 2x. Because our powers of powers do multiply. So we'd have 4 to the 2x. And our log base 4 of 4 would simplify, leaving us with just 2x. So it has worked out that the number inside the logarithm has simplified to a number squared. So the first time it was 5 squared. This time it is 4 squared, which ended up leaving us with 2x. So it's worked out nicely that it worked out in that way in both of these cases here. Any questions on these here so far before we look at the next one? Let's look at these here. So number 13 is 8 to the log base 8 of x. So what would this be? It'd just be x, because 8 to the log base 8 would simplify out, leaving us with just x. Number 14, log base 7 of 7 to the negative 3x. It'd be negative 3x, because log base 7 of 7 would simplify out completely, leaving us with just negative 3x. Now that brings us to number 15. I'm going to write it down below so that I have a little more space. Now this one here will not work out to be 2x, like the last two did. Now for us to be able to simplify the logarithm, we really need to rewrite 64 as 2 to an exponent. So 2 times itself, how many times is 64? Well, 2 times itself, 2 squared is 4, 2 cubed is 8, 2 to the 4th would be 16, 2 to the 5th is 32, and 2 to the 6th is 64. So we can rewrite 64 as 2 to the 6th power, because 2 times itself 6 times is 64. So we rewrite this log base 2 of 2 to the 6x. Well, log base 2 of 2 would simplify, leaving us with just 6x. So log base 2 of 64 to the x is 6x. Any questions on any of these here so far? Any questions on anything we've done so far? All right, let's look at number 16. E to the natural log of 20 would be what? We could. What is the base for the natural log? It is E. Because logarithm for log, for log, it is base 10. For natural log, it is base E. ln has a base of E, log has a base of 10. So it'd just be 20. And we could type that in and it would tell us that it is 20. Any questions on any of this here? We feel good with this here so far? All right. Inverse functions. Now we can use the logarithm properties and the properties of logarithms to actually find the inverses of these functions. Because as we said, or as I said at the start of the class, logarithmic functions are inverses of exponential, and exponential are inverses of logarithmic functions. So if I want to find this inverse, well, I'm going to need to rewrite f of x as y is equal to 6 to the x. And the next thing we do in finding inverse would be to switch the x and y. Now, what do we want to do next? Because there's two routes we can go from here. We could, but the issue would come into the fact that then we would have the white root of x, which wouldn't help too much because, again, if we're wanting to try to find the inverse, we need to get y by itself. So we do need to use logarithms. So what we were doing yesterday, how we rewrote an exponential function as a logarithm, would be what? We would have log base would be, y'all remember back from yesterday? Is what would the base be? Of log base 6 of x is equal to y. Because when we did these yesterday, we said log base b of x is equal to y is the same as b to the y is equal to x. And this here would be our inverse function. And on the assignment, it's just going to have you do this here. It's not going to have you rewrite it as f inverse of x. It's just going to leave it as y. Now, there's another route that we can go for this here. Now, I know whenever I apply a log or I have a log where the base and what's inside are the same, they simplify out. Because as we just saw, log base 6 of 6 would simplify. Yes? So what we could do to this here is I can apply log base 6 to both sides of the equation. Because as long as we do it to both sides, do it to the same to either side of the equation, it does not change anything. But on the right side here, well, log base 6 of 6 to the y is going to become what? Log base 6 of 6 to the y is y. It's y by itself, and it is equal to log base 6 of x. We get the exact same thing here. So really when we're switching between exponential and logarithmic or logarithmic to exponential, what we're doing is applying that log to both sides of the equation. Because it'll simplify out. The log base b of b. Log base 6 of 6 simplifies and goes away. Any questions on this here?
So on the side where it's log 6 of x, how does that change for y?
No, I just moved it from I just flipped it. Because if we kept it the same, it would be log base 6 of x equals y, because log base 6 of 6 to the y became y. Any questions on this here? Any questions on anything we've done so far? Okay. Let's look at this other one here. Y equals ln of x plus 3. Now, luckily for us, they already have it as y equals. We don't have to change from f of x to y. So we can go on and do our first step, which has us flipping x and y. So we're going to rewrite this as x is equal to the natural log of y plus 3. Now again, we need to get y by itself, so we need to get it out of the natural log. So what did we say undoes a natural log? Because we saw it in the last problem, not the last one, but one of the last page. an exponential e, because e to the ln, the base, and the what we're putting it to match up. So if I put both sides to the e, on the right-hand side, e to the ln, base e, the base and that e match up, so they will simplify out. This e and the ln will simplify out, leaving us with just y plus 3. And on the left-hand side, we still have e to the x. Any questions on any of this here? Because really we're putting both sides to whatever the base is. Now for natural logs, the base is e, so we put both sides e to those powers. Now we're almost done getting y by itself. The last thing we need to do is what? You subtract 3 from both sides, telling us y is equal to e to the x minus 3. And that would be our answer here. Any questions on this here? Ready to look at some more? Yes. Okay. We have these two here. I'm going to write them down below because there's quite not enough room here. But we'll look at y equals 11 to the x first. Well, the first thing we can do is what? We need to switch the x and y, which would give us x is equal to 11 to the y. Any questions on this so far? All right, what can we do next? Log base 11 of x is equal to y. So we're just using that switching from exponential to logarithmic. If we wanted to do it the other way, we could say that log base 11 of x, and we can apply that to both sides. And the reason we're using base 11 because we want the side that we have 11 to the y to simplify out, because log base 11 of 11, this here will simplify out, leaving us with just y. And on the other side, we have log base 11 of x. And we get the same thing either way. Any questions on any of this here? Any questions on how this works?
Doing the second way,
Mm-hmm.
it's just log.
Mm-hmm. Yeah, it's the same as the other way. We're just essentially using the properties of logarithms to be able to get to it instead of just using kind of our switching method. Any questions on this here before we look at the other one? All right. So the other one we have is y equals the natural log of x plus 6. Well, luckily we don't have to rewrite f of x as y. We can go on and just switch x and y. So we have x is equal to ln of y plus 6. Now what can we do next? Right, we're putting both sides to the e power. So we have e to the x is equal to e to the natural log of y plus 6. Now on the one side, we do have e to the x is equal to, well, the natural log and e will simplify out completely. That's the reason why we use it, leaving us with just y plus 6. And last but not least, we can subtract 6 from both sides, telling us that y is equal to e to the x minus 6. Any questions on any of this here? Any questions on anything we've done so far? Natural log of x plus 6, e to the x minus 6. That's on the other screen. So I want to go on and graph this for y'all. ln of x plus 6. Second, e to the x minus 6 and x. Because we talked about not natural logs, but we talked about inverses the first time, and I showed you kind of where we graphed the function and then its inverse. It was reflected across the line y equals x. Yes? So if we look at this here, we'll see the exact same thing. That they're still reflected across this line. These are inverse functions, and they undo each other. And so it's helpful to know these kind of processes, especially when we're dealing with exponential growth or exponential decay, because they give us a way to solve for different values. So really we have both of these here, b to the x and log of x. B to the x and log of b to the x. So we can have them in either way, but they are still inverses of each other because they reflect across this line. And we saw more of the second one on the one we just graphed, where they're kind of flipping across this line, but we can also have it where they don't. But they are a mirrored image of each other across the line y equals x. Now, are there any questions over anything we covered so far today? Do we feel comfortable with those inverses? Well,